For this virtual lab, you will be recording some of the following information and answering 3 questions. Question number 1, how does temperature affect the rate of photosynthesis? Question number 2, how does light intensity affect the rate of photosynthesis? And question number 3 is, how does the amount of CO2 affect the rate of photosynthesis? Okay, so this is actually the amount of dissolved CO2, and here we've increased it, and then here we've decreased it, so now it's half full. Here is the temperature, and inside the container of water, we have a water plant. It could be Elodia, a water plant. And what you might notice is these little bubbles coming off of the plant. Now, hopefully you guys remember that the equation for photosynthesis, the inputs or the reactants are water and CO2, and then the outputs are sugar and oxygen. So what we see coming off this plant right here is a bubble full of oxygen, and that is going to help us identify how the rate of photosynthesis changes. Fewer bubbles, the rate is lower or slower. More bubbles, the rate is increasing. So I'm going to kind of take you through, and I'm just going to count, and then I will provide you a general table to record your results on the Google Doc that's provided. So first, we are going to test temperature. We're going to keep light intensity at 25, and we're going to keep CO2 here. So we're not going to change those. We're just testing temperature. Here we go. 1 bubble, 2 bubble, 3 bubbles. Okay, we got 3 bubbles in 10 seconds, so we're just going to measure it for 10 seconds. Now we're going to increase the temperature to 25 degrees Celsius. Oops. All right, here we go. 25 degrees Celsius. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 bubbles at 25 degrees Celsius. Now we're going to go to 40 degrees Celsius. Now, by the way, 10 degrees Celsius we can consider that cold. 25 is probably about in the 80s. And we get into the 40s, we're getting well into 100 degrees. Here we go. 1, 2, 3, 4, 5, 6. I'm not going to count that last one because it didn't make it. All right. So we have 6 at 40 degrees. Okay, and what you'll do is you will record that in the appropriate spot. Now we're going to test light intensity. We'll test light intensity at 10, 25, and 50. Okay, so we'll start at 10. We'll keep CO2 here, and we'll keep the temperature at 25 degrees Celsius. Here we go. 1, 2, 3, 4. Okay. We'll move it to 25. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now we'll go all the way to light intensity of 50. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we got 10. We're going to move that back to 25. And now we're going to keep temperature at 25 and light intensity at 25. And we're going to measure the amount of CO2 or dissolved CO2. Now we're at half. So we're going to measure it. I'm going to delete that. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we've got 9. Now we're going to increase it. One, 2, 3, 4, 5, 6. Okay. So in the appropriate table, you will record that, and then you are going to answer those 3 essential questions. Ultimately, at the end, I want you to create a conclusion, and I want you to identify the conditions, the optimal conditions in which photosynthesis can occur. So you're going to look for the most optimal conditions, the optimal temperature, the optimal light intensity, and the optimal amount of CO2 that allows the plant to produce, or the rate of photosynthesis is at the most, is at the highest. So you're looking for the most number of bubbles.